So in today's one, what we are going to do, we are going to learn how Python could be used for machine learning. And for that, I'm going to use a simple classification problem. So the classification problem is quite popular one I'm going to choose, which is called iris flowers. You can see there are three types of flowers: versicolor, setosa, and virginica. What are your observations? So as you can see, there's no clear visualization, but if you see the type of flowers, there are slight color variations, as you mentioned, but this might be due to different lighting, but we never know. And then also like the type of flowers, if you see the two types of flowers, and this one looks slightly different, right? I don't know whether you will notice this. And so I told you like this is a classification problem. They have collected about data about 150 flowers from 50 each. And then the measurements, the information that the data that they have gathered is all about the measurements of the sepal and the petal, right? So they have measured the petal and the sepal length and the widths. So we have four measurements. So in machine learning, we know that we have to prepare the data set before we start. So they have collected the type of flowers. So they have measured the petal and the sepal length and the widths together with the class length. So you have a label data set. Right. So I will brief what we are going to do, and then I will come back and we'll do. So let's start with the loading data set. Right. So for that, I'm going to switch to your notebook. Right. So what we have done so far is we have, okay, so this is the place where I stopped last time. So I'm going to create a session. Is it 6? And I'm going to talk about machine learning in Python, and especially the module that we are going to call is scikit-learn scalar. So the what we need to look at is this particular machine learning library in Python. There are many others, but we'll focus today this one, right? Right. So to explain how to use scikit-learn for machine learning in Python, I'm going to first of all load some data set. And if you go to data sets, you will notice that within this scikit-learn, you will see there are many other data sets are also available. So have a look at what those data sets are. So the function or the method that we are going to use is called load iris. So that's what I'm going to use first. The first step is I'm going to start from scikit-learn and I'm going to import the data sets. And then the first thing that I'm going to get is from the data sets, there's a method called load iris, which will load the data set, and then I will print. Right. See whether you can come up to this point. And if it is a success, please raise your hands. Okay, so if you go through the what is the outcome, you will see data as an array object. Actually, it's a NumPy array. If you particularly get data and then if you try to get the type of data set, you see it's a NumPy. So these are the four measurements that I have talked about. There are 150 data points. And then we have target, which is the outcome, you can see there are three numbers which represent the three types of flowers, 0, 1, 2, two versicolor, setosa, and virginica flower types. And then if you go inside, you have target names and description, a lot of information about the dataset. Right, I'm going to move on to the next part. Right, the next part is I'm going to, get this data in the target as X and Y. So simply I'm going to get X, we are going to assign data in the target. You sometimes call this is class label. So the idea is I'm going to say iris.data, or you can say iris, you can have square brackets. Within that, you can put data, or you can use a dot operator. And then y equals, I'm going to say iris.target. Now, if you want to visualize what is inside, maybe you can take the first 10 rows and the columns. We'll print the first 10 rows of X and Y. You hope you remember this is NumPy array, and then we can use the X 0 to 10, or you can say colon 10. So this will print the first 10 rows. Similar to that, we can say first 10 rows of Y. So you can observe that, you have 4 measurements, 10, and then the first 10 will be from setosa. Okay, similar to first 10 rows, if you want to print the last 10 rows, it's easy, and you will see the pattern as well. So X, you can say minus 10 and colon. I hope you remember we discussed this. So you can use backward indexing. That's the easiest way. Once you get used to this is direct. So simply this will print, give you last 10 rows of data as well as the class name. Right. This part is okay. Good. And thanks for sharing your answers with me. So let's visualize the data set. So in any data set, usually visualization plays a major role. And we have discussed matplotlib, right? So we can use matplotlib, pyplot as PLT. Okay, select the third column and first column and put it as a scatter plot. You can use scatter, but yeah, maybe same thing we can use with the plot command with the formatting string. So I'm going to use third column. There's a reason I will explain. Third column, so I put 2. Why I did this? Because then I am selecting 2, which I can visually represent as points. So I'm going to select the third column and the first column. I'm going to use red color and the circles. Right. So if I do this, you will notice you will get visualization like this. Right. So in this one, what we did, I said we get third and the first column and we plot it, and this is what we will get. If you take this to a separate window, it look like this. So my question is, what is your observation? And you can see that in originally we had 3 groups, but at least we see 2 groups here. What it means? It means that, one flower can easily be separated by other two, right? Do you notice that? Because you see two groups here. Clearly, there are two groups. So what you can infer from this is one class can be easily separable by other two, right? So this is not very clear because we have just used one color. So let's improve this so that we can clearly see the three, uh, flowers. So the trick that I'm going to use is I'm going to use fancy indexing or the binary indexing. The idea that we are going to filter out the data. So I'm going to filter out the data based on the class label, and then I'm going to plot in different colors. So first of all, I'm going to select Setosa. So that's what I'm going to do. So I'm going to use the same plot command, but right now what we have is we have the third column like this, and then we have first column like this, right? And then we have red color, right? So here I'm going to put a filter. So the filter that I'm going to put it here is I'm going to say the y value or the y value should be 0. So what it means, you are selecting the first class. Similar to that, here also you will see, so all the values which is equal to 0, which is we are going to filter out the data based on the class label, and then we put it red. And you can show. So if you run this, you'll observe here, it will select only, half of the data points here, or 1/3 of data points in red color. That's for red color. So similarly, I'm going to extend to other two classes. So other two classes, we have 1, and then we have 2. So you can notice that once you do that, okay, we have to provide different colors. I put green and blue. Okay, now it should be separable. Okay, you can see very interesting plot now. So try this one. You should see now this has been imported here. So you can see one class can be easily separable by other two, which is green and blue, which you can see here. There are some overlapping points. So we can improve this. We'll put a title saying Iris dataset. I will increase the font size. I hope I informed this earlier as well. There's a font dictionary. You can change the font size, the type, and color, and so on. I'm going to increase the font size to 20 points. Then I will set X label. This is petal length. Then Y label, sepal length, and then we'll put the legend for the 3 classes. Okay, so automatically came in. So I'm going to select that one. So I'm going to run. Okay, yes, now clearly see. Let me share you the code with you. Right. Now that we have taken up to this point, let me put this into a new tab. Okay, here is what we have. Okay, what are your observations? So you can notice in the Iris dataset, you can notice the Setosa is clearly separable from other two classes. We have versicolor and virginica, they are overlapping. So those two are a bit difficult compared to setosa. So that's a good observation. I think this is something that you normally do. Right. Now I'm going to make use of some of the methods available in scikit-learn machine learning library. The first one that I'm going to discuss is we are going to separate dataset as training and testing. So ideally, you will learn this if you are new to machine learning, that when you build the model for the evaluation purpose, we'll separate the data as train test. You build the model using training data, and then you evaluate based on the test data set. So the next thing that I'm going to discuss, I'm going to split the data as training and testing. So for that, we have to use sklearn.model selection, and there's a method called train test split. Right. So I'm going to create xtrain, xtest. These are the outcomes. That means your x is divided as xtrain and xtest. Similar to that, we'll get y train and y test. So the method is train test split. And you provide x and y. And you have to provide the test set size. If you do not provide it, it take 25%. So I'm going to go with 1/3 of the data point. So I'm going to say put 3. Right. Okay. I will explain this random state later on, but for the time being, I will say state equals, let me put 1. Right, good. Okay. So if you run this will separate the data points as X. So you can print the sizes, train shape, test shape, train shape, test shape. So these we can put. And we had 150 points. So it's separated as 150, 150, and so on. Right. So this is the code. So what we did here, we use a scikit-learn machine learning library to separate the data as training and testing. The test set size, I'm going to select as 1/3. So 0.33 means 1/3 of the data we use for the testing. So that means we'll make use of 2/3 of data for the training. Right. Finished? The date. Once you separate the data as train and test, the next point would be like we want to select a machine learning algorithm. We have to train the model. Training means like we use the training data, X train and Y train, and then we'll build the model, right? So we'll build. So building this one, so I'm going to use scikit-learn import its tree, and then I'm going to select classifier as tree decision tree classifier, right? I'm going to say random state equals 1. So the random state can be used to control the decision tree construction because there's a randomness which you can control in. So that's why I use random state 1. Right. Then we have to train the model. I'm going to say CLF classifier dot fit xtrain wide range. So we build the mission tree, right? And it's here. So let me run this. Okay, no errors. So we have selected the decision tree classifier. Actually, you can go to a scikit-learn and then you can observe there are many classifiers. If you go to machine learning, then in the page you might see there's a classification which lists all the algorithmically supported. So if you go to a classification problem, these are the models supported in scikit-learn. But what we are interested in decision trees, so you can go to the decision tree and then you can read more about like how you can construct decision tree. So the next one is I'm going to actually describe how you may get a tree like this, right? So that's what we have discussed so far, and then we have built the model. So let's look at how to display the model. So one thing you will notice once you build this, there are binary splits. So what I'm going to do is I'm going to use tree.plotTree method. And we have saved plt.show. So simply you are trying to plot tree. Ideally, I have to tell which tree I'm going to plot. I will say CLF to say that we are going to build the tree like this. So this one will be a very basic one. For example, it says X3. We don't know what X3 means, right? So hopefully we should provide more information. For example, feature names we can provide, and it's iris.feature names. Notice the difference when you use iris names and if you plot it. So this time instead of X3, you see petal width, right? Similar to that, you can put the colors as well. So we can say filled room. Right, you can notice that you will have a color outcome. You can also modify things like rounded room. Now, if you run this, you will get much better outcome. So I'll copy here. Right. Now let's open up this. Let's see whether we can understand this one. So you can notice, if you carefully look at your outcome, you can notice that in the decision tree also you can see setosa is easily separable. But here it doesn't say the class name, so we can modify a bit. So we have feature names. Here we have to say class name. It's the iris dot. Spelling mistake. Okay, so now be much more clearer. So let me share the code. Right now, let's open up this in new tab. I want you to discuss a few more things once we have the model with you, right? One is you can make predictions, right? So for example, make predictions you can do, like, remember, we build the model using, training. So we build the model using the training data. So now we can actually make some predictions for the test data set. So let me say this is predictions, and I'm going to use classifier dot predict method. So now I'm going to apply the test set, and you will get the predictions. So let's say print predictions. So it will be like this. So if you want to compare the predictions together with the original, so what is original? It's in Y test. You can compare the two and observe the outcome. So if you carefully look at the outcome, right, do you see any errors in the data? So we can map one to one. So if you're not controlled your randomness, then you might get a different answer, because it can, split differently. So here we have an error. Okay, there's another error here. Right. So remember, we divide the data set 1/3. Hopefully we have about 50 data points, 2 errors. Ideally we get 96% accuracy. So let's see whether we can get this. So now that we have observed check the predictions with the accuracy, predictions with the actual, so we can calculate the outcome as a percentage. So we can use sklearn.metrics, import accuracy score, and then we'll print accuracy score. I'm providing the test with the predictions. So of course, if you provide the two, you will get 96% accuracy. So this is the most common metric we use. We divide the dataset as train and test. In my case, 1/3 for testing and 2/3 for training. You build the model, and using the model, you reevaluate. Basically, you get the labels for the test dataset, and we compare. And now we got the accuracy score by comparing the two. There are two misclassification. We had 50 data points, so accuracy is 96%. Right. Now, one of the problems with this measurement is like we really don't know what are the exactly misclassification. So it's not clear because you get just the accuracy value. So if you know details inside this, maybe you can go for more information. So let me explain another metric, which is called confusion matrix, which we can use to get more information. So the next one, confusion matrix, which shows you the actual and predicted, and you can obviously see what are the misclassification. So for that, we have to use scikit-learn matrix, import confusion matrix. We have confusion matrix, and we'll print confusion matrix with the predictions. So now you can get something like this. So we have seen that in the model building, we build, separate train and test, and then we build the model and we'll evaluate based on this one, right? But when you build the final model, you can combine both the train and test. I'll come to that point later on. So that's one thing that I want to discuss. The next thing that I want to discuss is, right, what are the other measurements? Just the accuracy is not enough, right? So that's a point that I want to discuss. So to discuss that, I'm going to get this slide. So when you build classifiers, there could be like two types of errors. What are the two types? Assume that you have actual labels. So the actual class labels are here, yes and no. Then we build the model to make predictions. So we have predictive class, yes and no. So if the actual class is predicted as yes, that's what we call the true positive. If actual class no is correctly predicted, we say true negative. But the actual class is yes, predicted as no, we call false negative. Actual class no, predicted as yes, we say false positive. So this is what we call the confusion matrix. You see true positive, true negative, false positive, and false negative. So these are the formations, right? But then again, if you have three classes, it looks like this, and that's what you have noticed in our case. If everything is correctly classified, it should along the diagonal. So you should see the diagonal elements are the correct classifications. Off diagonal elements are the misclassifications, right? So that's what we need to witness first. So going back to my what we have discussed. So in our case, if you look at it, so you can notice that the actual values here, and these are the predicted values. So the actual values, we have three classes, Setosa, Virginica, and Vesicolor. And this prediction is also Setosa, Virginica, and Versicolor. So you can say Setosa is correctly classified. This is purely separable. The other two classes, there are two misclassification. So the third class classified as second class, and then we have second class misclassified as third class. So two classifications happen like this among the two classes, right? So in obviously, you know that what are the misclassification in your data. Now, if you ask me like why this is important, right? Of course, normally this misclassification has different cost. We call cost sensitive learning. Now, for example, we have just means cancer and no means, let's say, no cancer. So the two errors are, right? A cancer patient we can classify as healthy patient, and healthy patient can be classified as cancer patient. Which one is more critical? So cost sensitive meaning that the errors that you make in a classifier has different meaning, different costs involved. So the cancer patient case we discussed, classifying cancer patient as a non-cancer patient is more dangerous than non-cancer patient classified as cancer patient. Right. Going back to the next ones. Although accuracy is the only measure that we have discussed, there are many other measures: precision, recall, confusion, and so on. So we have discussed accuracy and confusion metrics. So let me discuss the precision and recall. The two measurements actually came with document retrieval, like in Google search, for example. In Google search, what happens usually, you type something and you expect some documents to come in, right? So what might happen is, out of all the documents, when you put a query, you will get a set of documents. So let's say what is inside the circle is the selected ones. So in the search engine, ideally, this would be the outcome. Now, from this, there are some relevant ones. There are some not relevant ones. So that's why whatever the selected documents, relevant ones, we say true positive. Not relevant ones, we say false positive. We predicted as this, yes, but actually it's no. Right. What is precision is, if you get this true positive, whatever the relevant documents that you have selected, as a proportion of the all the documents that you have selected in the query, we say it's a precision. How accurate the documents that you have retrieved, right, will be the precision. On the hand, recall means how many relevant items are selected. So there are some relevant elements, and out of that, you have selected this portion. It's called recall. So you can focus on these two cases, precision and recall, as other measurements. Very important when the data is unbalanced, for example. Right. So with that said, I can go back. So I'm going to share the code again. Right. So what we have discussed so far is, given a data set, we build the decision tree classifier, we calculate the accuracy, now the confusion matrix. So further, I would like to explain how we can, look for the other measurement as well. So if you want to get everything like precision, recall, and information, so there's something called classification report, which gives us everything. So let me give you the code for this one. So this is how we can get for this. We will say from sklearn.metrics import classification report. And then we can say print classification. Sorry, we have to go to the next. We'll go to the next slide. Report print classification report. Y test. So you can notice that it shows you like this. Precision recall, and F1 is actually combination of precision recall. So ideally, it's a combined measurement of these two. And then now it says 0, 1, 2. This is the three class labels. So we can actually replace this one. Let's put target names. We have Setosa, versicolor, virginica. Right. So we have put that. So let's put this here as well. Predictions. Target names equals target names. So you can notice that Setosa, that this is clearly separable from other two. We have noticed in the beginning. So precision is 1, recall is 1. That's what we have noticed. Versical on the other, precision is 0.95, recall is 0.95, Virginica 0.93, 0.93. So accuracy is 50. So these are the number of instances, right? So you can have a look on everything from this. If you want to build the final model, right, you have to make use of all the data. So therefore, training and testing, evaluation purpose, but to build the final model, we can say classifier, we can use X and Y, which means all the data points. And if you want to visualize, I missed the method fit here. Yes, you build the final model. Now to visualize, you can get the same code. I'm going to copy, paste the same code. So this will be the final model visually, how it look like. And we are going to use pandas to read HTML data. So the command is very simple. I'm going to use data frame. And then I will use, okay, first of all, we have to import the data. Sorry, pandas, import pandas SPD. Right. And then now we'll go to data frame and we'll say read. Okay, the command is HTML. And then you can provide the URL. So I'm going to copy here. And then as a single, within single quote, as a string, I will put the URL here. Right. Now, first of all, you can look at the outcome. So I'm going to just run it. And you can observe what you have. So you can see some information extract in multiple different ways. So if you can carefully look into, you can see there are different types of data is available here, right? So I'm going to take the first row here. So I'm going to use df0. So that's the first row. So if you extract the first row, you can notice that now we will get only the table here, right? And then we have this information. Right. Now, let's say if you want to extract only part of the data, you can select what you need. So, for example, I can say out of this one, we are going to select, let's say, 2025 ranking. And then maybe I can have another list. Okay, this is what I need. And 2024, what else I need? We have, let's say, the programming language, this one. So if you do that, right, we should be working. Yes, okay. So you can notice that I have extracted just a ranking and then the programming languages. So this is something that I actually missed from last time, extracting data. Right. Um, One last thing, the getting data from databases. So you can try UCI data repository. I think I have mentioned this earlier as well. So for example, we can go to Iris. This is already, we have the data. And then So how do you import in Python? It's also given here. It says, okay, so you can actually see how you may actually use this, or else you have to directly access the data. So let me see whether the data is directly accessible. So usually, okay, we have iris. So the data is set is here. Right, let me copy this one. So I'm going to copy this one. One way to access the data from the UCI repository. We might have to install, but let's run and see whether this is already there. It's not there. So that means we have to install. So when you're installing, make sure that you use exclamation mark pip install UCI ML repository. And then we will, okay. Okay, now we have the data set. Yes. Actually, one way to do that is if you can find out this information that this was not directly available, you can directly read the data from here. It shows CSV. So I'm going to just try it out. I'm going to copy the link address. Let me give you the commands first. I'm going to give you this. We were discussing about how to use datasets available in UCI repository. So this is one way from their website. The other way is if you know how exactly the data is stored in the place, the CSV file, you can directly callable. So what I did actually, if you look at here, it says data URL, it's already available. So I'm going to just copy the link address and see whether it's work. So traditionally, we used to directly read, like for example, we can say data frame. We can say pd dot read CSV, and then we can provide the URL or the CSV. This should work fine. Let me say DF. Let's see whether this is working. Yes, it's working. So you can notice that. So if you have access to the direct link for the data, that you can actually get the data directly, right? And from this point onwards, how do you handle it? It's similar to what we have done early. You can follow the same way. You can build the tree structures, everything what we have discussed so far. Everything will be the same. Right. Maybe we could try another one. Maybe we can, okay, we can go to data sets. Since we use the data type numeric, maybe we can say attributes. Okay, so those are attributes. Let's say what we have. Okay, feature type. We'll select only numerical ones. Okay, you can see iris comes here, right? So we have some data points which you can use, right? We have student performance. Let me see how we can handle that one. Okay, so again, direct access to the data is not given here. Right. So how do you import? Right. So I'm going to go back. Yeah. It'll show you the information and repository is there. Can we find the URL as well? I'm just looking at whether it's possible. Yes, we have. Okay. So we can. Oh, so this was directly not available, but earlier we used to have this. So that's why I said. So we can say data frame equals pd.read CSV, and then we provide this. And then data frame. So you can notice, right? You can get the details directly. Okay, I think, yeah, this is enough for the today's session. So just to summarize, our focus for the today's session was explaining you how to make use of machine learning in Python. For that, we focus on scikit-learn library. We use the existing data available there, the iris dataset, and I have explained through from the beginning, visualize it, build a decision tree model, as well as briefly discuss model evaluation. So I think with that said, now you have a good understanding about how Python can be used for machine learning purpose as well. Right. So the next week, I think now that we have looked for, we can talk about how to pre-process data. So the data preparation, as well as how to prepare the other types of data. Right. For example, how do you convert free text data into a format that we can use for machine learning purposes? So that part we'll cover in the next class. So with that said, we'll conclude the today's session and we'll meet next week. Thank you.